We're going to be going over 1.3 and 1.4 notes, which is segments, rays, distance, and angles. The first video, we're going to talk about all the definitions and postulates we need to know for 1.3, and then we'll get into examples in the next video, and then move on to 1.4. So all of these definitions correspond with things you're going to see in your textbook. I just wanted to relay them out for you so that I can kind of discuss them with you a little bit. If you can print this out at home, excellent. If you can't, I highly recommend taking some notes in a notebook. But keep in mind, all these definitions are in your textbook. So if you want to, more use your textbook for some definitions, that's fine. I recommend writing down what you think you need if you can't print this out. So for 3.1, we're going to be talking about segments, rays, and distance. So first thing I want us to do is, if you notice this little diagram I put up in the right-hand side here, we have our line, and I want you to label these points, points A, B, and C. Okay, so this would be line AC, line AB, line BC, any combination of two letters that lie on that line. Now, segment, if a figure is a segment, then it consists of two endpoints and all the points between them. Now you'll notice how I have this definition structured. This is how we're going to be structuring our definitions from now on in class. These are called if-then statements. So if you're given this, then we know that. So if a figure is a segment, then it consists of two endpoints and all the points between them. So if we take this line, there are actually several line segments within this line. One of those segments would be segment AC. So I'm just going to take it and kind of draw it outside of our picture because it's important that we know how to draw these things. So I'm going to draw a little segment, put my two endpoints, A and C, on it. Okay, so that's what that would look like. So that's segment AC, and you don't have to draw it at the same size as the diagram above. I just wanted to have something to reference for you guys. And then as far as labeling, you would take the two endpoints and put a bar above it in any order. So segment AC is the same as segment CA. They're both endpoints, so it doesn't matter what direction you're going in. Another thing to keep in mind, a line, you need at least 2 points to make a line, but a line has an infinite number of points on it. Same thing is going to happen in a segment. Sure, you have your two endpoints, but there are an infinite number of points between them. Then we have a ray. If a figure is a ray, then it has a fixed endpoint and extends indefinitely in one direction. So again, there are several rays in this diagram. I'm going to point out ray BC to you, and what that would look like is you would have your endpoint, and it's going to extend forever in the other direction, right towards another point. So this would be ray BC, and how you would label that is you would put your BC with a single-sided arrow above it. The arrow above always goes to the right because the direction that we write this is important. This is ray BC, which means it starts at B and heads towards C. If I wrote ray CB, that's actually going in the other direction. So that first letter indicates where our endpoint is. So it tells us where our ray is headed. Okay, so for example, up above here, if I said ray BA, that's starting at B, heading towards A. So the order you write that in is important. And it's one of the few times that the order there is important. With lines and segments, it doesn't matter. With rays, it does matter because they only go in one direction. Then we have opposite rays. If two rays are opposite rays, then they must have a common endpoint and form a line. So we also have a set of opposite rays in our diagram. That would be ray BC and ray BA. So ray BC and BA are opposite rays because they both start at B and they extend in opposite direction. So B heads over to C, goes to the right, B to A, right, it heads to the left, and they form a straight line. And then length. If a number is a length, then it is the absolute value of the difference of two coordinates of, if a number is a length, then it is the absolute value of the difference of the coordinates of the two endpoints. So a lot of the times you'll see numerical values assigned to these points, kind of like on a number line, and the length is just the absolute value of the difference. And it has to be absolute value because length is always positive. We can't have a segment that is -5 units long. There is also some important labeling that happens with length. So let's say I told you, and you'll hear me refer to length as measure very often, but let's say up in our diagram here, I said that from A to B there was a length of 5 units, or that segment AB had a measure of 5 units. How you would write that down is AB with no bar above it equals 5. This means that segment AB has a length of 5, or you could say segment AB has a measure of 5. So those are a few different ways to say that, but when there's no bar above it, that's giving a numerical value. Congruent. Congruent is going to be a very important word for us this year. Our definition, if two figures are congruent, then they have the same size and shape. And there's a special symbol for congruent. It is an equal sign with a little squiggle above it. Congruent segments. If two figures are congruent segments, then they have the same length. So I'm actually we should draw this. I recommend that you draw this as well so you can see what this looks like. So let's say I had segment XY. One second. Okay, so let's say I had segment XY. Sorry, my stylus is glitching. 1 second. Okay, so we're going to have segment X, Y, and we're going to have segment AB. Try to draw them about the same length. It doesn't have to be perfect. Okay. Sorry that my handwriting just severely deteriorated. My good stylus stopped working. Let's see. Okay, so let's say I have these two segments, and let's say I told you that both of these segments had a measure of 5 units, whatever it is. That means that these two segments are congruent. So how you would write this is that segment XY, don't forget your bar above it, is congruent to segment AB, also with a bar above it. And there should not be a little mark there. Let me redraw this. This is very sloppy. So again, you have two segments. I'm going to say I have segment AB and segment XY. If they both have the same measure, let's say hypothetically it was 5 units, we would say that segment XY is congruent to segment AB, and that's how that would be written, or the other way around. You can also say that their measurements are equal. So you could also say the measure of XY equals the measure of AB. So when we're naming the segments, it's important we use our segment bar and the congruent symbol. But when we're talking about their numerical value, you don't put a symbol above it, you just have the letters, and then you use an equal sign. And then another important thing to mention is that sometimes your pictures will use some labeling. If things are congruent, then that's marked with little dashes. So if each segment has one little dash in it, that means they're congruent. If they each have 2 little dashes, that means they're congruent, and so on. Our next vocab word is midpoint of a segment. If a point is a midpoint, then it divides a segment into 2 congruent segments. So let's draw ourselves a segment here. I'm going to draw segment A, B. And if you have a midpoint, it needs to go in the middle. I'm going to call that point M. So this midpoint divides our segment into 2 congruent parts. Okay, so we can put our tick marks or our dashes to signify these are congruent. And the way you would write that is that segment AM is congruent to segment MB. So M is the midpoint of segment AB. Bisector of a segment. If a ray, segment, line, or plane is a segment bisector, then it intersects the segment at its midpoint. So again, let's look at a similar picture. Let's draw segment AB again with midpoint M. But let's say through midpoint M, you had line L. M is the midpoint, but line L is the segment bisector because it goes through that midpoint. So you could say that line L is the bisector of segment AB because it goes through that midpoint. And then our last vocab word is postulate. If a statement is a postulate, then it is accepted without proof. So this is a statement that we don't have to explain. It is a fact. And when we get into proofs, we'll be using both definitions and postulates very often. Our only really important postulate for 1.3 is the segment addition postulate. And that says if B is between A and C, then the measure of AB plus the measure of BC equals the measure of AC. So how this would look in a picture, it's telling you that point B is between A and C. That's going to imply that they're lying on a segment or a line. So let's say you had your segment. This is telling you that A and C are on that segment and B is somewhere between them. Not necessarily in the middle, just between. So what this postulate then tells us is if we take the measure of segment AB and we add it to the measure of segment BC, it's going to give us our entire segment measure, which is AC. So basically, you just take your different parts to make a whole. And then in our next video, I'm going to get into some different examples.